Welcome to the Department of Aeronautical Engineering NIET. Today in this laboratory class, we will learn how to conduct an experiment with forced convection over a flat plate. In this forced convection setup, we are having a flat plate which is connected with the electrical source using the solenoid coil for heating the flat plate, and a centrifugal compressor which is used to blow down the air from the atmospheric condition. The purpose of carrying out this experiment is to learn the heat transfer problem in the gas turbine engines. The heat transfer problems are common everywhere. In the gas turbine engine, the cooling of combustion chamber, cooling of turbine blades are much important in order to increase the performance of the gas turbine engine. Regarding the heat transfer, there are three modes of heat transfer. First one is the conduction, and second one is the convection, and third one is the radiation. In case of the conduction, the heat transfer takes place from a solid body. The second one, in case of convection, the heat transfer takes place between the two mediums, from solid medium to the fluid medium. And third one is the radiation heat transfer, in which the heat waves are radiated as the electromagnetic waves to the external atmosphere. So here we are having the forced convection setup. Using this forced convection setup, we can calculate the heat transfer from the plate to the atmospheric air. So in this case, we are going to blow down the air over the heated flat plate, and it will extract some quantity of heat transfer, and we are going to calculate the coefficient of heat transfer. This experiment is based upon the Fourier law of heat transfer. K is equal to minus QA dt divided by dx. So let's see what are the experimental parts in this setup. At the bottom of this experimental setup, we are having an opening through which the atmospheric air enters into the centrifugal compressor, and this one is the heating plate, and this one is the centrifugal compressor. So after switching on this experiment, the current will be supplied to the flat plate. Here we are having 5 thermocouples in order to measure the difference in temperature across 5 locations of the flat plate. Using the thermocouple, we can measure the temperature, and it is displayed in the digital board. And the purpose of centrifugal compressor is to supply the constant mass flow rate of air for the purpose of convection. Here in this case, as the name implies, the forced convection. The convection is done with the help of external atmospheric air whenever it is blown down by the centrifugal compressor, and a pipe which is connected to the U-tube manometer, which is used to measure the velocity of air exiting the centrifugal compressor after the convection process. So let me switch on this experimental setup. First of all, we have to switch on the electrical heater. So it is switched on, and we will switch on the display boards. In this display board, we can measure the current supplied in ampere as well as the voltage of the electricity supplied, and here we can get the display of the thermocouple values. Already I mentioned 5 thermocouples are located on the flat plate at different locations. So here we are having the measurement of those 5 thermocouples with respect to change in time. So let me switch on this motor. By adjusting this knob, we can control the current supplied as well as voltage of the current entering into the solenoid cable, and we can measure the temperature at 5 different locations. So using the difference in the temperature levels, we can calculate the coefficient of heat transfer for the flat plate.